Good morning, children. In today's class, we are going to learn a new concept called limit. Have you ever heard this word limit while talking? Yes, people used to say, don't go beyond your limit, isn't it? So, limit tells us some borderline like. Here, mathematically, how am I going to define limit? See, this is a value. X approaches A. X is not exactly A. X is approaching A. Can I approach only from right side? No. I can approach from left side also. Consider your school gate. Not necessary. You must approach from right. So this is the gate. You are almost entering. By the time bell rings, are you in? No. So you have almost approached the gate. Whenever I am using the word, I have almost approached, we say it is the limit value. It is not exactly A, but we have almost in. So that idea I call limit. How do you write it? L-I-M. How do I read it? Limit. You can also write it as LT as an abbreviation. Limit X tends to A. X is not equal to A. X is nearing A. Limit X tends to A. F of X equals L. That L I call limit of F of X. Now I said you can approach from right. When I approach from right, it is A plus values. So I call limit X tends to A plus. That is, I approach A from the right, from the values that are more than A. So this I call right limit. The same idea, I can approach A from the left. What does it mean? Values below A. Values to the left of A. So this I call left limit. Suppose left and right are equal. We declare limit exists at X is equal to A. How are we to do the problems? If they ask you left limit, in the problem given, say f of x is equal to x square plus 2x plus 5, something like this. And I want limit x tends to 1. Wherever x is coming, I will put 1. Check whether I get these type of answers. If I get these type of answers, I cannot determine. That is indeterminate form. I need to apply some of the formula to reduce the problem. But look at this problem. X square plus 2x plus 5. Limit x tends to 1. Wherever x is coming, if I put 1, it is 1 square plus 2 into 1 plus 5. I get 8. A proper answer. So I will call this as the limit. Some problems you might have like this. X minus 2 by x minus 2 into x plus 3. My question is limit x tends to 2. If I put limit x tends to 2, see what happens. 2 minus 2 becomes 0. Down also 2 minus 2 becomes 0. So I come across 0 by 0, which I call indeterminate. Whenever I am not able to find the answer, I call it as indeterminate. 0 by 0, infinity by infinity, combination of 0 and infinity. 0 is called nothing. Infinity is called everything. But one person's nothing cannot be compared with another person's nothing. Similarly, one person's everything cannot be compared with another person's everything. Now for me, 10,000 may be a huge amount. But for a rich man, even 1 crore is not a huge amount. See, huge amount differs. For a child to an adult, huge amount differs. Nothing differs. So, these ideas we call indeterminate. In such cases, try to factorize the denominator, cancel the problematic factor, and then apply the limits. So these are some ideas how to do. As we do exercise problems, we will be little more familiar with. Now, suppose you are asked to find left or right limit. What should you do? Wherever x is coming in the question, put a minus h. If my question is x tends to 1, put 1 minus h. Wherever x is coming, put 1 minus h and then put h tends to 0. Expand it, simplify. Finally, wherever h is coming, put h tends to 0 and you will arrive at an answer. Supposing I want right limit. X tends to 1 is the question. Right limit tells me 1 plus. So wherever x is coming, put 1 plus h. Expand it, cancel like terms, whatever you can simplify, do it. Finally, wherever h is coming, put h tends to 0. In a particular problem, if left and right limits give you same answer, I will declare limit is that answer. Some results that we need to remember, limit being a new concept. If you have f plus g of x, limit split for addition, limit of f of x plus limit of g of x. Similarly, f minus g is coming. How should I write it? Limit of first function minus limit of second function. Remember to write x tends to a whenever you are writing limit. F into g of x. Now also limit is split for multiplication. Limit f of x into limit g of x. F by g of x. Now the formula, limit f of x by limit g of x. Whenever we write a term in the denominator, ensure that it is not 0. So 0 should not come in the denominator. These are the properties or some special results I can say. Whenever we are learning a new concept in mathematics, we should know the basic operations in that concept. Now limit is the concept. If plus symbol comes, you can split it. Minus, you can split. Multiplication as well as division, we can split and write. See, one limit here. When I write here, limit of first plus limit of second. The same idea. If 2 into something is coming, keep 2 as it is. Apply the limit for the function. So, k into f of x is coming. Keep k outside the limit. K being a constant. It will not be affected by the limit. Limit is only for x. So, k you can keep as it is. Put limit in. Limit of f of x. Some more limits that we can remember as standard results. What are they? Very first one. Limit x tends to a. X power n minus a power n by x minus a. Notice x, x, a. Here the power is n. Answer is n a power n minus 1. Whenever limit x tends to a. When you are learning a formula, learn along with every letter that comes in. X tends to a. Denominator x minus a, numerator same x minus a with the same power. Both the powers may be 2 or 3 or even a fraction. N is a fraction. What is my answer? N, a power n minus 1. The next idea, limit theta tends to 0. Sin theta by theta or tan theta by theta. My answer is 1. In the standard limits, many answers give rise to 1. What are those? Let us remember well. The very first one is sin theta by theta. What is theta? Limit theta tends to 0. Similarly, tan theta by theta. Limit theta tends to 0 and theta is in radians. If so, my answer is 1. Similarly, log of 1 plus x by x. My answer is 1. The reciprocation is here. E power x minus 1 by x is also 1. In both the cases, remember limit x tends to 0. Now you have two formula with e. E is an irrational number. E power x is a reverse function for logarithm. When do I get e? Limit x tends to 0, 1 plus x whole power 1 by x is e. These two interchange here. But now the limit x tends to infinity. So x tends to 0, 1 plus x power 1 by x is e. When x tends to infinity, 1 plus 1 by x power x is e. If you are thorough with these formula, any type of limit problem is at your step. You can easily do it even within seconds. So understanding limit is an easy concept provided we are thorough with the results. Limit split for addition, subtraction, multiplication and division and even scalar multiplication. Standard results must be thorough with so that we can face exercise problems easily. Exercise 5.2 question number 1. Evaluate the following limits. Subsection 1. Limit x tends to 2. X cube plus 2 by x plus 1. As I see the problem, let me directly substitute. That is the first method. Wherever x is coming, put 2. So it becomes 2 cube plus 2 by 2 plus 1. 2 cube, 2 into 2 into 2. 8 plus 2 by 3 or my answer is 10 by 3. It is a proper limit. So that is my answer. When you have limit x tends to infinity, take x out. Down we have x squared to be higher degree. Take x squared out. So remember the trick. Whenever limit x tends to infinity is coming, take highest power of x out. So here x is highest. Take it out. We have, what do you mean by taking a number out? Divide everything. So if I take x out, it is 2x by x plus 5 by x. Same way, the denominator x square is the higher degree. So take x square out. Every term divide by x square. The next step, x and square gets cancelled. We are left with limit x tends to infinity, 2 plus 5 by x. Denominator x into 1 plus 3 by x plus 9 by x squared. Remember, any number by infinity, my answer is 0. Suppose I take a number 5. What is 5 by 10? It is 0.5. What is 5 by 100? 0.05. What is 5 by 1000? 0.005. See, as I keep on increasing the denominator, my answer is keeping on decreasing. So when the denominator is infinity, my answer will be 0. So remember the idea. Any number by 0 gives me infinity. Any number by infinity gives me 0. Now apply the limit. I get 2 plus 5 by infinity divided by infinity into 1 plus 3 by infinity plus 9 by infinity. Whenever I have by infinity, my answer is 0. So 2 plus 0 by infinity into 1 plus 0 plus 0. Again, I get 2 by infinity, so my answer is 0. Whenever infinity is in the denominator, my answer is 0. So limit x tends to infinity tells us, take x out here, take x square out here. As we cancel, we arrive at denominator as infinity. So my ultimate answer is 0. Instead of doing all these steps in objective type questions, remember, if limit x tends to infinity is coming, denominator power is more compared to numerator, immediately put the answer 0. Suppose numerator power is more, my answer is infinity. So these are objective type questions, no need of steps. Limit x tends to infinity, denominator degree is more than the numerator, put the answer as 0. Third subdivision, limit n tends to infinity, sigma n by n square. What is sigma n? It is 1 plus 2 plus 3 up to n. The formula n into n plus 1 by 2 divided by n square. N and square gets cancelled. We can write it as limit n tends to infinity by 2. I can keep separately. I am left with n plus 1 by n. That is limit n tends to infinity 1 by 2 into n by n plus 1 by n. N cancels one time. Apply the limit. First term is 1. Second term 1 by infinity. Infinity in the denominator tells it is 0. So half into 1 plus 0. So the answer is half. Evaluate question number 1, subsection 4. Limit x tends to 0, root of 1 plus x minus root of 1 minus x by 5x. If I directly put x as 0, this becomes 1 minus 1, so 0 in the numerator. 5 into 0, 0 in the denominator. So what do I get? 0 by 0. Can I get 0 by 0? No. So if I directly substitute, it is 0 by 0. That is indeterminate. Whenever indeterminate comes, go with some of the results or any of the other methods. Whenever root symbol comes, you remember the technique multiplying and dividing by the conjugate. So the given question is limit x tends to 0, root of 1 plus x minus root of 1 minus x by 5x. Multiply and divide by the conjugate. What do you mean by conjugate? They give you minus in the middle. You put plus. We multiply, we divide. So the answer is unaltered. The next step. Numerator becomes a plus b into a minus b. It is a square minus b square. Denominator 5x root of 1 plus x plus root of 1 minus x. The next step, limit x tends to 0. Square and square root cancels. I am left with 1 plus x minus square and square root cancels. I am left with 1 minus x. Denominator 5x into root of 1 plus x plus root of 1 minus x. Now 1 plus x minus 1 plus x divided by 5x into root of 1 plus x plus root of 1 minus x. Which gets cancelled in the numerator? 1 and 1. I am left with 2x divided by 5x into root of 1 plus x plus root of 1 minus x. Limit x tends to 0. X and x cancels. 2 by 5. Now since I have cancelled, I can apply the limit. 1 plus 0 plus root of 1 minus 0. It is 2 by 5 into root of 1 is 1, root of 1 is 1. 1 plus 1 is 2. So we get 2 by 5 into 2, cancelling 2. The final answer is 1 by 5. The same problem. Suppose 5 is missing here. Everywhere I hide 5. What is my answer? It is simply 1. So, if they change and give the problem with any number, instead of 5x, 3x, 2x or simply 1x may come, you must know to attempt it with any number. So, what is the special method? Multiplying and dividing by the conjugate. Conjugate tells us minus becomes plus. Definitely I will get a square minus b square pattern. In that, as I simplify, the numerator and denominator, the term will get cancelled. Then you apply the limit. Wherever x is coming, we put 0 and we get the final answer to be 1. So the problem here, limit x tends to 0, root of 1 plus x minus root of 1 minus x by x equals 1.